This is Tessa, Claire, and Brandon's video project. We will be demonstrating rotational dynamics in a few aspects of gymnastics.
Here we have a giant on the high bar into a double back tuck flyaway. Because of the ice skater theory, when the gymnast tucks into a ball, the distribution of weight is moved toward the center of mass, thus giving it a positive angular acceleration. During the rotation around the bar, the angular velocity is calculated to be 3.65 radians per second. During the first backflip, the angular velocity is calculated to be 8.85 radians per second, giving an angular acceleration of 1.56 radians per second squared. During the second backflip, the gymnast's angular velocity is calculated to be 26.18 radians per second, giving an angular acceleration of 15.07 radians per second squared between the two flips. These calculations show that angular velocity is greatly increased by moving weight toward the center of mass. The total angular acceleration in this example is 6.02 radians per second squared.
In the second example, we have a gymnast performing giants around the bar into a layout flyaway where he stays in the same body position he was in for the giants. Because there is no change in the distribution of weight, there should be little to no change in the angular acceleration. During the rotation around the bar, the angular velocity of the gymnast is calculated to be 2.76 radians per second. As the gymnast goes into the layout flyaway, the angular velocity increases by 1.66 radians per second, giving a new angular velocity of 4.42 radians per second. The angular acceleration that happens as the gymnast goes into the flyaway is 0.25 radians per second squared. Part of this acceleration can be explained by the loss of the frictional force between the gymnastic's hands and the bar when the bar was released. This shows that by keeping the distribution of the weight the same, the angular velocity will stay approximately the same throughout the skills.
Thank you for watching this explanation of how rotational dynamics work throughout a few of the gymnastics skills.